Finding stuff like this is one of the reasons I love to read. So before we get started, I need everybody to look at the top of the video and notice where this is coming from. It is from Hopkins Medicine. This is from Johns Hopkins Medicine website. It's official. It's not conjecture. It is not from the National Enquirer. It is not a conspiracy theory. This is from Johns Hopkins. So it says, Johns Hopkins researchers engineered tiny shape-changing machines that deliver medicine efficiently to the GI tract. It was published on November 3rd, 2020. Theragrippers are inspired by a parasitic worm that clamps onto its host's intestines. Then this picture, a Theragripper is about the size of a speck of dust. This swab contains dozens of tiny devices. And if you look really closely, you can see the little specks on there. Those are the little devices. Again, it's from Johns Hopkins University. Here you can see a picture of the Theragripper when it's open. On the left is the open one. On the right is the closed one still wrapped. I just thought this was really interesting with all the swabbing that's going on in the world right now. Maybe we should pay attention. And here we go. Inspired by a parasitic worm that digs its sharp teeth into its host's intestines, Johns Hopkins researchers have designed tiny, star-shaped microdevices that can latch onto intestinal mucosa and release drugs into the body. David Gracias, a professor in the Johns Hopkins University Whiting School of Engineering, and Johns Hopkins gastroenterologist Florin Celeru, director of the Johns Hopkins Inflammatory Bowel Disease Center, led a team of researchers and biomedical engineers that designed and tested shape-changing micro-devices that mimic the way the parasitic hookworm affixes itself to an organism's intestines. Made of metal and thin shape-changing film, and coated in a heat-sensitive paraffin wax, Theragrippers, each roughly the size of a speck of dust, potentially can carry any drug and release it gradually into the body. The team published results of an animal study this week as the cover article in the Journal of Science Advances. Gradual or extended release of a drug is a long-sought goal in medicine. Celeru explains that the problem with extended-release drugs is that they often make their way entirely through the gastrointestinal tract before they've finished dispensing their medication. Normal constriction and relaxation of the GI tract muscles make it impossible for extended-release drugs to stay in the intestine long enough for the patient to receive the full dose. Says Celeru, who has collaborated with Gracias for more than 10 years. We've been working to solve this problem by designing these small drug carriers that can autonomously latch onto the intestinal mucosa and keep the drug load inside the GI tract for a desired duration of time. Thousands of Theragrippers can be deployed in the GI tract. When the paraffin wax coating on the grippers reaches the temperature inside the body, the devices will close autonomously and clamp onto the colonic wall. The closing action causes the tiny six-pointed devices to dig into the mucosa and remain attached to the colon, where they are retained and release their medicine payloads gradually into the body. Eventually, the Theragrippers lose their hold on the tissue and are cleared from the intestine via normal gastrointestinal muscular function. Gracias notes advances in the field of biomedical engineering in recent years. We have seen the introduction of dynamic microfabricated smart devices that can be controlled by electrical or chemical signals, he says. But these grippers are so small that batteries, antennas, and other components will not fit on them. Theragrippers, says Gracias, don't rely on electricity, wireless signals, or external controls. Instead, they operate like small, compressed springs with a temperature-triggered coating on the devices that releases the stored energy autonomously at body temperature. The Johns Hopkins researchers fabricated the devices with about 6,000 Theragrippers per 3-inch silicone wafer. In their animal experiments, they loaded a pain-relieving drug onto the Theragrippers. The researchers' studies found that the animals into which Theragrippers were administered had higher concentrates of the pain reliever in their bloodstreams than did the control group. The drug stayed in the test subject system for nearly 12 hours versus 2 hours in the control group. And then it lists a bunch of other people that were involved in this experiment. Anyways, I just really thought that was interesting, that you can fit dozens of these tiny little autonomous machines on the tip of a swab. And it's, official.